if we kind of look at the news from any sources, the word decarbonization comes up quite often. Actually, I did a Google Scholar search of the word decarbonization. I think it hit about 1 million searches or million items. So this is kind of a topic that is very current. And as I tell my prospective students, if we want to work on something where we can have a multi-generational impact on society, this must be one of those which we do not get to work on very often. With that said, I have been at UCF. So I have been at UCF since 1997, as I was mentioning before the thing started, that I have seen the place change tremendously. I have graduated 33 PhD students over this time. But my main activities really started in the middle of 2000s. And when I realized that we in Central Florida have got a tremendous ecosystem of companies, which we do not always advertise. Meaning, if you think of all the turbomachinery related companies that are globally responsible, we see a very large number of those are here. For example, just turbine for power generation aviation, I think 6 out of 7 have got strong presence in Florida, which means they hire our students, talk to us for research and things like that. And that was basically the reason for genesis of this center, catered, that informally started in the middle of 2000s and then officially started in 2012. The current, obviously, we have changed because the topics are changing, the society's needs are changing. If we look at the current center-wide initiatives, our main focus, decarbonization is definitely one of those, and so is hypersonics and supercritical CO2 power systems. And then there are a few others that are not as funded, but still are being funded to a lesser extent. And if we look at our overall faculty numbers, there are 10 core faculty from MAE, there is 1 from statistics. And if we just focus on the 10 faculty from MAE, the last full year, fiscal year, the per faculty funding was 787K. That is actually more than many very well-known College of Engineering per faculty numbers. And the graduation was 1.6 per faculty. So you can multiply by 10 and get the numbers. With that said, let me move to the actual topic. So when we talk about decarbonization, I would say that we see a lot of talk in the media and not necessarily always they explain what is going on there, right? For example, if we say that we like to limit the emission of carbon dioxide, which then we should be limiting emission of all greenhouse gases. And greenhouse gases are those gases that when in the atmosphere, they tend to absorb the Earth's radiation, whereas they let the solar radiation come through because of their spectral characteristics. And then we have to address all those gases. On the left-hand side of the chart, you see that it is just not CO2, but there are other methane and nitrous oxides that should be also considered. And hence, probably greenhouse gas is a broader name than just focusing on CO2. On the right-hand side, we see that it is just not electricity that produces these greenhouse gases. Actually, if we say electricity, we probably should also use heat, because the northern states, they use quite a bit of fossil fuel for their winter heating requirements. But also we see that agriculture, forestry, transportation, industry, they're all, and buildings, they're also greenhouse gas producers. So in other words, we need to look beyond just electricity and heat and fossil fuels. We need to be broader, because otherwise it doesn't make sense, because we just focus on one and not focus on the others. Then what good are we really doing? So with that said, let us now focus on some of those that I mentioned, other areas, and not all of those are easy to decarbonize, meaning take the CO2 out. For example, if you look at aviation, aviation has got very strict requirement on the gravimetric and volumetric energy density of the fuels, because weight to drag ratio is a key parameter for aviation. So we cannot just put up anything there to drive the propeller. And that creates a huge problem in selecting how we should decarbonize aviation, which is currently dependent on kerosene as the jet fuel. So we, for example, started a NASA-funded project led by UCF and a lot of other companies and universities are there, 5-year, $10 million project where we are trying to propose ammonia as the energy carrier for aviation. And you probably have heard me talking about that in my last the CCS talk. Another very difficult to decarbonize sector or topic is actually some of the industries. For example, here it shows the example from steel industry. Now in that industry, you need coke, which is basically metallurgical coal, to reduce the iron oxide, and also you need limestone, which is calcium carbonate, right? So if you do all those processing, you have got to get CO2 out of the stack. So how and modern society cannot live without steel, and as it cannot live without cement and fertilizers, which are also heavily CO2 producing. So we have to think a lot broader than solar PV or wind turbines, because none of which can directly help here. So we need to broaden our definition of how to decarbonize the society, because when these greenhouse gases goes to the atmosphere, then the radiation does not care whether it is coming from automotive or it is coming from airplane or some other sources. So you have to broaden, and that is why I highlighted the word holistic, because that we need to look broader than that. But now let us look at something else. Ask ourselves, we meaning in US, how are we doing? So our partner in the city, in the town of Orlando, Mitsubishi, they have actually partnered with Carnegie Mellon to create quite a few years ago what they call carbon tracker or carbon index. And you can see that the power sector CO2 emissions actually have been gone down 40% below the 2005. And you may say, okay, what that is electricity? What about all sectors? Well, on the upper right-hand corner, you can see the all sectors is also, well, it went up in the 2000 timeframe, 2005 timeframe. That was the peak. And since then, it has come down quite a bit to the level of about 1990. That is total emissions. But now if you think of per capita, and that is over here, even there you see that it is going down. And that is actually very important, because a lot of people, especially there's a McKinsey report that says how modern civilization, the standard of living is directly correlated to the amount of greenhouse gas that we emit. And then we come at a very difficult point. What are you going to do? But the point is, in US, we are actually reducing per capita CO2 number. But that is US, and US is not all, right? So we need to talk about the rest of the world. And you see that actually, and EU is doing very well too. Actually, EU, if not, might be doing better than US, but both are doing very well. And if you just look at them, they're barely 1/4 of the whole global CO2 emission. And then again, this graph comes from EPA, so US government agency. And so point is, decarbonization in just US and EU will not get the job done. We can beat each other to the end, but still 75% of the CO2 emission would remain unaddressed. And that is actually the main thesis of my talk today, to say that we have to go look at global, and we have to also have solutions, technological solutions that actually work for the whole world, and not just here, because the needs are different. So at this point, I'm going to show a kind of disturbing picture that says that we are actually, other part of the world is going the opposite. On the left-hand side, you see that and these are very recent in the last few months, that in Africa, they set up a new oil pipeline, and the government said, okay, we have to first talk about our population's well-being and their standard of living before we can do anything else. And how do you argue with that? Unless we have got a solution to provide to them. And that is what we need to think about, and that is what I'm trying to say. On the total right-hand side, you see the same thing. China approved equivalent of 2 new coal plants a week, not a year, a week, in the whole of 2022. So that is like more than 100 coal plants. Just a few days ago, about less than a month ago, I was traveling to one of the airports in India. And if you do not know, India is the chair hosting the G20 meetings. So they are the president of the G20 committee. And this airport is bragging how they have got the second largest coal mine. So I say, well, which century are we living in that we are still bragging about coal mines? The point is all happening because the carbon-based technologies are so much related to modern way of living that we have optimized over the last many centuries. So let us look at some graphs here. On the upper left-hand corner is what I actually captured not too long ago from World Bank database. It talks about US per capita energy consumption in kilogram of oil equivalent per person, and it has stayed pretty steady. Has not gone too much down here. Now you may say, okay, that is, let us look at this number 7,000. How does other countries do? Well, China is 2,000, India is 600, Tanzania is 500. I could not find Uganda. Remember, one of the pictures on the last slide talked about Uganda. And then you ask, well, if we say that carbon emission or greenhouse gas emission is directly related to standard of living, and there are a lot of progress need to be made in the rest of the world, what are you going to tell them? Just you guys do not you just stop growing. So it is a very difficult question. It is just not global anymore. It is a question of equitable and affordable. Obviously, the big question is that any new technologies, how affordable they are for. If they cannot even get coal and run and get the electricity, then how can they have some of the more expensive technologies? You probably may have seen in the news about South Africa, and which I'll actually be coming up in the next slide of mine. On the lower left corner is actually a different slide, but it is a little dated. So in this case, the brown line is actually US line over the years, and the bars are the current number for a specific country. And then we are showing, for example, if we look at United Kingdom, so United Kingdom's current per capita number is what US used to do in 1968 or so. So if United Kingdom decides, say, okay, now I'm going to spend energy at the same level that my colleagues in US do, then they are going to be doubling. They have to double. And then you can go to the other countries, China and India and the rest of and the Africa, you see the same issue. So the question really is that I'm trying to pose to the everybody broader group is how to make decarbonization in an affordable and equitable manner, how to compute the true cost of decarbonization. The reason all this is happening because we are not always calculating the true cost of decarbonization, which by the way also includes social cost. It is just an economic cost. Then engage the international policymakers and create an international dialogue. So maybe the political science or the humanities side of UCF, we can all work together and try to approach globally some of these issues. Now, the 4 countries that we are trying to target are in India, Qatar, Brazil, and South Africa, just to be globally broad and have very different type of environment and reasons for what they are doing right now. And actually, we have set up the first one of those, which would be a conference in India that we are going to call Decarbonizing India. That would be in December. Similarly, we are already talking with Qatar and Brazil. South Africa, we started talking with them, but then with the recent problem in terms of the whole grid is actually collapsing in South Africa, the whole electricity grid, and people have got a lot more serious problems on their mind. So maybe I'll catch up that discussions a little later. So with that said, I'll go to my last slide. Well, everything that I showed, a lot of credit goes to my colleagues in Qatar. And as I mentioned, there are 10 in mechanical aerospace and then 1 in statistics. Obviously, all my past and current students and postdocs, they do the work, I do the talking. But also more importantly, the SUS of Florida Turbine Initiative and Florida Center for Advanced Aero Propulsion, which we created in 2006 and 2007 respectively, that has created pretty much the whole state of Florida's turbomachinery research. So we cannot say enough thing in recognition of that. And just I picked up one specific group from 2010, and you can see because of the practicality of what we do, because we connect with real companies, they're all pretty well positioned, including even a faculty at Purdue, and there is another one whose picture is not here. He's a faculty at UC Irvine. So with that, I'll end my talk.